Hi, this is Jimmy to talk about the progress of the optimization project. In the project proposal, I propose an algorithm to evaluate the best pattern of gates for both efficiency and stability. Now I'm going to talk the details of the nonlinear problem. First, the cost function is to evaluate the best pattern. In my project, I choose 3 gates as choice and consider 6 circumstances, which is a combination of 2 weather conditions, non-skid and slippery, and 3 terrain flight, 15-degree slope and 30-degree slope. And according to the research of this gate instructed in my project proposal, I formed a table of possibility of losing control. And our goal is to stay relatively safe in a long time. So I write down the formula. The score for losing control is the sum of all time multiple the probability by the sum of the time. The range would be in 0 to 1, and similarly, I generate a score for time, as the average velocity is shown in the table. To form a percentage value, I calculated the maximum time and minimum time, which is calculated in the fastest velocity and the lowest velocity. It's all time in gate 3 or all time in gate 1. The sum of the two scores with a coefficient as the final evaluation score. By choosing different coefficients, the user can choose a preference for efficiency or stability or balance. The variables of this problem is the Tij, which is the time taken in gate I in case J, and the cost function is the final score. Next is about the constraint. The first constraint is the distance. Sum of Vt must be bigger than the set distance. The second constraint is the battery endurance should be better than the battery power losing. So the sum of Vt should be less than 100%. There were a third constraint for the step number must be an integer, since the robot moves discretely. However, as the problem is considered in kilometers, one more step would only move meters forward, thus there is no need to constrain the step to be an integer. This is why I replaced the combination of step length and the duty ratio with the velocity. The next thing to do is to code in MATLAB and take some tests. Thanks for your time.